Yo, what's up, everybody? Here's a little video for you about the segment addition postulate. So segment, let's start with a segment here. Pretend that segment is nice and straight. I did the best I could. And we're going to say, hey, there's segment, we'll call it AB. We'll call it AB. And we'll say, hey, there's a point somewhere between A and B. And we'll call it point F. All right, so we could say that A, F, and B are collinear, which we should know by now, means that they're all on the same line together. A, F, and B are collinear, and F is somewhere between A and B. All right, so our segment addition postulate says that if I were to take this little guy, AF here, and I add the other little segment, FB, then together, you can probably see how that works there. Together, AF plus the length of FB, that would give me the whole entire distance there. And the name of the entire distance would be AB. So AF plus FB equals the whole distance AB. In other words, one of the parts plus the other part is going to equal the whole thing. So we can remember segment addition as a part plus the other part equals the whole. All right, in this case, there's just two parts. So that's why there's one part, two part, but that segment could be broken down into more parts. As long as when we add them up, segment addition, that it equals the whole thing. So let's get a look at some examples here. Our first example has a bunch of words. It says that H, J, and K. So I see the capital letters. That tells me that that's point H, point J, and point K are collinear. So I'm going to draw that segment where H, J, and K are collinear, and J needs to be somewhere between the two. So we'll put J between, and H and K will be the endpoints. So it said that they were collinear, and remember, collinear means that they're on the line together. All right. It says HJ is 13. So when I see this, I'm going to be like, all right, HJ, you get to be 13. And it says that HK is 28. So the distance from H to K is going to be 28. So the question says, what is JK? What is, and because they don't have hats on top of them, there's no segment hat there, I know that it means what is the length of JK. So the length of JK would be that unknown right there, the distance from J to K. So I know that you guys are looking at that and you're like, yeah, 28's the whole thing. So let's do 28 minus 13. That'll tell us what JK is. And you're right. JK is going to be 15. But if I wanted to do this the legit professional way, I would say the segment addition postulate states that HJ, this part, plus the other part, plus JK, needs to equal the whole. And the whole thing is called HK. So I know that you could probably look at that and say, hey, the answer is going to be 15. But the legit way on a proof or to show your work is to write out this guy, the segment, my handwriting's getting bad. The segment addition, and that word is postulate. All right, segment addition postulate. And then we would use the substitution property. We're going to plug in the numbers. I know that HJ was 13. I don't know what JK is, so I'll leave that as X because I don't know it. And I do know that HK is 28, so 28. And there you guys see it. You have a little one-step equation. You could use the subtraction property, and you would see that X is equal to 15. And in this case, X is the distance JK. JK equals 15. All right, guys, I know that was an easy example, and I made it a little more complicated than it needed to be because I wanted to show you this piece. All right. I wanted you to be aware that you could sometimes see it like that. Let's look at the next example. Oh, there it is. I almost skipped it. On example 2, they already have the picture drawn for us. So I'm going to jump straight to that segment addition postulate. The segment, I'm going to abbreviate too. My pen's not working very good. Segment addition postulate. Okay. And I see that the part is AC plus the other part is CB. And it needs to equal the whole thing, and the whole thing would be all the way from A to B. So there's my segment addition. Now I'll use the substitution property. Let's plug in. What was AC worth? AC was worth 6. CB was worth 2x plus 10. And AB was worth, the distance from A to B was worth 36. All right. Now when I solve this, I've got some algebra to do. The very first thing I would do is I would combine these like terms. When I have the same kind of terms, in this case it's the constants, on the same side of the equal sign, I need to combine those. So we'll call that 16, positive 16, right? So I have a 16 plus 2x equals 36. All right, little 2 steps. We can subtract 16 on both sides. 2x equals, what is that, 20? And divide. Y'all might hear my dog barking. He's an old man. It's like, I think he's 15 years old. Or maybe his next birthday he'll be 15. He's an old pup. So x equals 10. I didn't really give very good directions on this problem. I didn't tell you whether to find x or to find the distance from C to B. So we know x is 10. If I did tell you to find CB, well, you'd be like, well, CB is 2x plus 10. And you know that x is 10, so you could substitute and be like, okay, that's 2. And we said x was 10, so plop it in there. 2 times 10 is 20. Plus 10 makes 30. So we knew that the distance here from C to B was 30 units. And let's make sure that makes sense. If this CB is 30 units and AC is 6 units, that totally makes sense because 30 plus 6 had to add up to 36. All right, guys, so on that one, we had a little bit of algebra to do, and we learned what to do if we needed to plug the number back in. All right, I got one more example. Again, if these don't make sense, if you're still confused after watching this video, come see me before school. You can come see me during a lunch. On the next one, we got... That's about it. You can go to tutoring. Oh, yeah. We got tutoring in the math lab. And that's in room, I think, 707. All right. If you get lost, if you're not sure where that is, come to me and I'll walk you there. Cool. All right. Last example. Points X, Y, and Z are, there's that word again, collinear. So again, they're on the same line. So when you see this question, you got to draw it. You got to draw it. And it says, oh, I didn't write this. I should have written that Y was between. So I should have written Y is between. Why didn't I do that? X and Z. So if I was a good teacher, I would have written that. So we got segment Y somewhere in here. Let's put it here just for fun. I try not to put it exactly in the middle because I don't want you guys to get confused with the midpoint, which will be like one of the next things we learn. So we got Y is between X and Z. And it says that XY is -1 plus 2x. And it says that YZ is 11. And this one even tells us that XZ is 3x plus 3. So it gives me all that information. And it says, hey, what's x? So the first thing we're going to do is we're going to set up our segment addition postulate. I'll be like, all right, I know that the part plus the part has to equal the big papa. And the part, our first little part here is xy, and our next little part is yz. My pen is not working super good. And the whole thing, big papa, is xz. All right, so there's my segment addition postulate. And now let's use the substitution property. Let's plug our numbers in. So xy, we're just replacing it with its value, -1 plus 2x. Plus sign. Yz. Well, yz is worth 11, so write 11. Equal sign. Xz is blah, 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 blah. 3x plus 3. That's a 3. All right, so everything's in the right place. Let's do a little bit of algebra. And again, I got some like terms. I got these constants over here. Let's put them together. Because they're on the same side of the equal sign, I've got to combine them. So -1 combined with 11 makes 10 plus 2x equals 3x plus 3. Now I got x's on the left, I got x's on the right. I need them all on the same side. So you could do a couple different things. The way I'm going to do it, I like positive numbers. So I'm going to subtract this 2x on both sides because I've got to get all my x's to one side. And since that was a positive 2x, I have to subtract it over. Bye. Now I've got 10 on the left. And I've got 3x minus 2x, which leaves me with 1x. And we're still trying to solve, so let's move that plus 3 to the other side. Remember, your goal is to get all your letters on one side and all your numbers on the other side. And I've got 10 minus 3 is 7 equals 1x. I'm not going to write 1x, I'll just write x. Okay, the one's there, it's imaginary. So x is 1. If I wanted to be sure, I would plug it back in. If I plug it back in up here, that's going to be -1 plus 2 times 7. 2 times 7 is 14, so -1 plus 14, and -1 plus 14 is 13. So that little chunk is 13. Down here, again, we're plugging in the 7 just to make sure everything works. And I've got 3 times 7 plus 3. And that's 21 plus 3 makes 24. So let's see if our segment addition works out. The left part was 13. The right part was 11. And the whole thing was 24. Hey, those numbers, they add up. It all adds up. Very cool. I hope you learned something. If you didn't, I'm super sorry. We'll get all your money back to you. Have a good day. Make good choices. Bye.